It was talking about a flow rate, saying that the rate with which the cars flowed, and you know what we didn't do when we set this up is just look at a graph. What does this picture look like? Or, you know, what does the graph look like? It's a parabola and it's upside down. So we have some sort of parabola. It starts at 500 and then it's an upside down parabola, so theoretically it goes like that. Now, does that make sense that that's what the flow rate of cars through the intersection would be, starting at 6 a.m. and then going until the end of the day, you know, presumably 6 p.m.? Should an intersection start out not very busy in the morning and then get busier and busier throughout the day and then get less busy at the end of the day? Yeah, this is a very reasonable model. And so what we're saying is, since this is the flow rate, then if we were to compute an area, right, that means that we're computing base times height. The height is a rate, which is cars per hour. And then the width is a time period, which is simply hours. And when you multiply cars per hour times hours, the hours cancel out and you get cars. So it's reasonable to interpret that if we take the integral of a rate, the answer should be a number of cars total. And that's the concept. That's what we're looking at. That if you take the integral of any rate, the answer is going to be the total amount. So let's just say that I had the rate of gallons per minute, that I turned on my bathtub faucet or who knows what, and I can calculate the rate of how many gallons per minute I'm using. Then if I were to do the integral of that rate over a particular time period, like let's say I turned on the bathtub faucet at 6 a.m., not that I would put 6 a.m., but at time 0, and then I left the faucet running until time 10, so for 10 minutes you're filling your bathtub, then by doing this integral, you're going to calculate the total volume of water. And that's interesting, folks. It's interesting that you can know just a rate of something, and then by taking an integral, you can calculate the total amount of the rate that you just were looking at. And that's what this problem is doing. So by taking our integral, we'd have the integral of 500 plus 600t minus 150t squared. And we're doing this from when? 6 a.m. to 8 a.m. So we go from 0 to 2, because they tell us that 6 a.m. is time equals 0. We do that integral and we're done. So what's the first thing you have to do this integral? A little prep work. What do you always do before you actually integrate or differentiate? You have to make it look good, make it look pretty, make it look user-friendly. So I rewrite this as 500t to the 0, and then plus 600t to the first, and then minus 150t squared. You have to be able to clearly see those exponents in order to take an integral, in order to do the power rule. So now let's do the power rule. Add 1, divide by what you get. So t to the first, that's 500 over 1. And then plus t to the 2, that's 600 over 2. And then that's minus t to the 3, that's 150 over 3. And then I put plus c at the end. Oh, no, actually, I don't do plus c at the end, because we are actually going to evaluate this from 0 to 2. So I put my evaluation line from 0 to 2. And then again, we clean it up. So we have 500t plus 300t squared minus 50t cubed, all evaluated from 0 to 3. I hope you'll notice the symmetry here, that in the beginning of the problem, you either have an integral symbol, then at some point you change over, and then you start having an evaluation symbol, until you actually get to the end and you do parenthesis minus parenthesis. Elsewhere?
You put 0 to 3, 1, and 0 to 2.
Oh, thank you. I did that to see if anyone was looking, Josue, and you were, so I appreciate that. Okay, so now, you always finish an integral by doing parenthesis minus parenthesis. So in the first parenthesis, I have to do all that evaluated at 2. So that would be 500 times, okay, let's see, can we do this in our head? 500 times 2 is 1,000, plus 300 times 4 is 1,200, minus 50 times 8, minus 50, because 2 cubed is 8, so minus 50 times 8 is minus 400. So that's all that I have to evaluate. What's nice about this second parenthesis?
0.
Yes, it's 0, right? Because we're plugging in 0 all the way across, so it all comes out to be 0. So we end up with 2200 minus 400 is 1800 cars. So that's a total of 1800 cars that pass through that intersection. So folks, just to point out to you, let's say you wanted that answer during the test so that you could check to see what your answer is. Well, you don't have access to Desmos during the test. So even though I can sit here and do the integral from 0 to 500 plus 600 x minus 1 x squared, I can do that. And the answer is 1800. So good, that works out. Do you all want to know how to do it on your calculator? Would you like to know how to do an integral on your calculator so you can know ahead of time what the answer is? Okay, everybody, let's do it. Everybody, take out your TI. And of course, my TI just died. So I need to find my batteries. I hope I brought some batteries. Honestly, who walks around without batteries? Haha, my bag of batteries. I mean, come on, don't you all have a bag of batteries in your backpacks? How do you live without a bag of batteries? What if your calculator goes dead? You all think that I'm just some funny jokester carrying around batteries. That's for situations like this. Are any of you going to start carrying around batteries in your backpack now? Like, wow, Mr. G, that sure was convenient. You had no downtime at all. You just got to keep on calculating. All right. All right, folks, everybody have out their TI or whatever calculator you're going to use. Hot diggity. So, everyone, ready for the instruction? You're going to, on your calculator screen, go to y equals. And then under y1 equals, you're going to type in the formula. 500 plus 600x minus 150x caret 2. Or if you just want to type x squared, that's fine. So we're all going to type in the actual formula, 500 plus 600x minus 150x squared. Now, if you go to the graph part, now hit, well, finish typing that in, then hit graph. Depending on what your window looks like, you may or may not have a good graph. Like for instance, my window is going negative 10 to 10 and negative 10 to 10. So all I see is two vertical lines, and it's not very helpful. But the good news is it doesn't even matter if you can't see the graph. You can still do the integral. So everyone, regardless of what your graph looks like, now I want you to go to second trace. Right above it is the word calc for calculate. So if you hit second trace, now if you look down that list, option number 7 on my calculator says integral f of x dx. Your option might be in a slightly different place. But if you go to second calc and then scroll down the list, eventually you'll get to an integral. All right, so go down there and choose that integral symbol. Now hit enter. Now, on your calculator screen, it says lower limit. And what they're asking is for the lower limit of your integral, which in our case is 0. So right now you can just straight up hit 0 and then hit enter. And then it will change the question and say upper limit. And so now the upper limit is 2, so you hit 2 and then hit enter. And some shading should have appeared on your screen. And the answer 1800 should have appeared on your screen. So I'm just going to walk around real quick. Okay, it worked. Do you have one in general? Like, what are you going to use on Monday? Good. Okay, so you're going to borrow one and bring it. Did it work, Brandon? Sweet. So now you have it, and then you hit second. Oh, that's what I'm sure. So second trace. And then you go down to option 7. Just need a 50, that's 500. Right? There we go. Nope, still no. That's x squared, that should be fine. 500 plus 600 minus 150 x squared. You got something, oh, plot 3 is on. I don't know what that means or what plot 3 is, let's turn it off. There. So now whatever the graph shows, now you can go to second calc. You go to option 7. The lower limit will be 0, upper limit is 2. No, I did that. No, yeah, that's correct. And then it traces it and then it is. Did it work ever? Oh, well, so touch base with me on Monday. Because in theory, folks, I'd like for all of you to be able to do this. Because why not be able to? And you just got maybe forgot it. So you're gonna bring it, right?
Yeah, so they're really big.
Okay. Well, what does that have to do with whether or not you keep your calculator permanently in your backpack? Whether you're layering out your calculator and a sack of batteries should be in your backpack. Okay, what's that? Did it work?
Yeah.
Okay, good. Did it work?
No, I don't find, no, because mine is.
Yeah, you're
Yeah.
a little strange. Do you have a TI?
Yeah, it's really good. But we did it on hers, and I wrote down
Okay,
the
did it work?
instructions.
Okay, super. Okay, good. Okay, great, Stephen. Did it work? I don't know how to use that calculator out there. And it did work. Okay, so a few of you didn't bring a calculator. I'll bring extra calculators on test day. A few of you have fancy TI 89,000s that make it hard to use. Oh my gosh. So those of you who didn't just get to do the integral, let's touch base on Monday, and I'll bring extra calculators with you and help to make sure that you can check your work. Again, though, the point is this is just verifying your answer. In order to get full credit on the test, you have to actually do the integral. This is just allowing you to check to make sure that you got the right answer. Yep. All right. So number 15. Let's do number 15 real quick. 15 works the same way. It says here a company's marginal cost function is c prime of x equals 11 over root x, where x is the number of units. Find the total cost of the first 49 units. So we're going to go from 0 to 49 of the cost function, which is 11 over root x dx. And that's the integral we want to find. So again, what's the first thing you have to do with any integral? It's the first thing we did here as well. We wrote down the integral, but then we made it user-friendly. We made it look good. So we need to change 11 over root x. We're going to change that and make it 11x to the negative 1/2. Right? Because root x is really to the 1/2. And then you push it up to the numerator, so it becomes negative, and you have 11x to the negative 1/2. You know what's really funny is, I mean, when you think about it in context, all those rules that you learned in previous classes, like negative exponents and the square root is 1/2, and how to multiply things like x to the a times x to the b equals x to the a plus b. All these rules that in another class, you just practice those rules over and over, and you just got tested on the rules. These are the rules that you just use as a matter of course in calculus. It's just assumed that you know how to do it. So these rules really do finally come to play here. All right, now let's do the antiderivative. You add 1, divide by what you get. So how do you add 1 to negative 1/2? Negative 1/2 plus 1 is really negative 1/2 plus 2/2, which is positive 1/2. So I add 1 and then divide by what I get with an evaluation symbol from 0 to 49. So I hope you have that phrase burned into your mind. Add 1, divide by what you get. Add 1, divide by what you get. Add 1, divide by what you get. So what's 11 divided by 1/2? And so again, like this is a fraction skill that you probably drilled over and over in like 5th grade or 6th grade. How do you divide 11 by 1/2? At this point in calculus, it's hoped that you'd be able to do that in your head. 11 divided by a fraction is the same as 11 multiplied by the reciprocal. The reciprocal of 1/2 is 2, so 11 times 2 is 22. And you can do that whole thing in your head. So 22, x to the 1/2, that's really the square root of x. So now we have that we just have 22 square root of x evaluated from 0 to 49. Now again, just kind of checking yourself. Notice the symmetry. First 2 lines, we have integral symbols, but then it switches to evaluation symbols. And all along, we're just kind of cleaning things up. Like we write down the problem, we make it user-friendly, we do the antiderivative, we make it user-friendly again, and then you always end the problem by doing parenthesis minus parenthesis, because that's the fundamental theorem of calculus. That you plug in the top number, so 22 root 49, and then plug in the bottom number, 22 root 0. which is
150.
154. Of course, that term goes away. So square root of 0 is 0. And there we have it. Now, folks, it's been a while since we've done any Excel work. And by a while, I mean, I think we did it in the very first week. And then since then, we've maybe looked at Excel once or twice. But I'd just like to now point out to you what this problem just did. So they're saying that the marginal cost function is given by 11 over root x. So look at here. We're going to look at the total cost of the first 49 units. So the 0th unit, I'm not sure how much that makes sense to have the 0th unit, but the first unit, second unit, third unit, fourth unit, fifth unit. And so I'm going to go ahead and scroll that out all the way to 49 units. There we go. So there's the first 49 units. And we can calculate the cost of each of those units. So I'm going to write equals 11 divided by the square root of that number. There we have it. So now that was the marginal cost of the first unit and so on. I'm going to scroll that all the way down. So look at what this does for us. Can you all see these numbers? Let me make this a little bigger so we can actually see. Here we go. How do we make it bigger? 11. There we go. So look at what this marginal cost function did for us. The first unit costs $11. The second unit costs $7.80. The third unit costs $6.40. The fourth unit costs $5.5. Now, does this make sense? What's happening to our cost of each unit as we go down? Yeah, the cost is getting less and less. And that's because of economies of scale. You know, typically if you buy in bulk, you get a discount. So if you're only buying, one item from a manufacturer, then it'll cost you $11. But if you say, hey, I'll buy 20 from you, they'll give you a discount, and then you're only paying less for each additional item. So now, that's the marginal cost of all of those items. And I want to know, the question was, that's the company's marginal cost function. Find the total cost of the first 49 units. So now what happens if I add all those units together? That would be the total cost of all of those units. So I'm going to take all those. And let's see, is there a formula that says add them all up? Oh, auto sum. And there we have it. The answer this gave me was $139. Pretty close. Not the exact same. And why was it not the same? Like, this actually added up each value at precisely the function input of those numbers. Whereas if you actually look at the graph, so now let's actually look at the graph of 11 divided by square root x. There, and we want to do, oh, you know what I can do even better? I'll show you Shodor. Shodor, integrate. My Excel spreadsheet technically just did a Riemann sum. I did 11 divided by square root x. Gosh, that's square root x, and I'm going from 0 to 49. And I'm going to do a right-hand sum, I think. Oh, it's not going to let me do 0. I'll do 0.001. I'll cheat. And then the number of partitions I'm going to do is 49. Okay, I'll go faster by typing it in. Oh, it didn't let me type it in. It's not letting me type it in. Oh no. I've ruined everything. Start over. There we go. 11 over square root x. I know what I'll do. I'll just go from 1 to 49. And then the number of, oh, no, I still have to sit here. Okay, so you can see there's the graph. You can tell it's a decreasing graph. The cost of each item is going down, down, down. And if I get to 49 partitions, I went from 1 to 49. Technically, I wanted like 0.0001. What do we get? No, that's wrong. Oh, because that's too tiny. Oh, because it's technically a 0. Well, there, I'll tell you what I'm going to do. This answer came out to be 137 point that. If I just take off the very first entry, no, that's not going to work. Well, anyway, This is kind of a diversion. You can tell that we're all in the same ballpark now. The Excel spreadsheet said 139. The Riemann sum said 137.03, but the actual integral gave a value of 154. And the reason is, you'll notice in the Riemann, these rectangles pop out a little bit. Oh, actually, that's what it is. I should be doing a right sum. There we go. See, the rectangles aren't actually filling the curve completely. So by doing this Riemann sum, oh, now I can do it. 1, 2, 1. There we go. I wonder why the whole graph went away. Well, there we go. Yeah, so there's the 138, which was the 138.7. That's the value I got from the Excel spreadsheet. The point is that the rectangles are below the graph, and so it's an underestimate. Yeah, these Riemann sums, because the rectangles are below the graph, it's underestimate, so 139 is too small, the actual value is 154. Because the integral is actually calculating all of the area, not just the individual chunk-sized rectangles. It's actually capturing all the area under the curve, and it's not missing out on any of those little bits where the rectangles are covered. Okay, in any case, that's the end of the problem. So, that's it for section 3.3. So your practice test, the practice test I've made for you has 22 problems. And going all the way back to Alexis, on the first test, she said, hey, can you tell us which ones you plan on putting in and which ones you don't plan on putting in? These are just the problems that I found most important, so these are the ones that I'll probably put on the test. There could be a couple of those that I don't put on the test. But basically, you can expect to see all of these, more or less, on the test somewhere. And you'll notice that there's actually only 20 questions. Even though it goes up to 22, there is no number 2, and there is no number 8. So your test is roughly 20 questions. It'll be a little less than that, a little less than that. And in fact, I think it's only 3 pages front and back. So what I'd like everybody to do now is go ahead and come on up to the board and sign up for a problem to present. First come, first serve, no pushing. And then I'm going to walk around the room and just answer questions.
I can't.
Are you letting your daughter have a good nap?
No.
Yeah, take the one out your mouth. You don't deserve it.
Well, that's hard.
Wow,
I'm not going to let my daughter drive a car right now either. But I'm not going to stop driving a car. I do let my daughter drive my car, actually. In the cul-de-sac, I'll let her sit on my lap and she can just kind of move the wheel around. How's your daughter? 2. We never go more than 5 miles an hour. Very, very slow.
I grew up driving too, so it's all right.
Wait a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Gosh, that seems like a lot of people. Sign up for one. Hey folks, there's still a lot of Kit Kats up there. If anyone wants any Kit Kats. Or maybe you're like Mr. G, I hate Kit Kats. That was very fortunate.
I was eyeing him to see if anything. Post way you want.
All right, folks. So we have an hour and a half about. So over the next hour and a half, I'm going to walk around the room and offer to help each of you with your practice test. When I get to you, please have at least one question that you want to go over with me. Do not say, oh, I'm okay, I don't have any questions. Find a question. Find something that you want to go over. Otherwise, while I'm walking around the room, we'll have people coming up to take turns to write in solutions. Don't pay any attention to them. Just let them stand up at the board and fill it out. And then when they're all done and they sit down, then I'll call for your attention. And we'll look at the solution, and then we'll move on. Now, I noticed that there are a variety of problems up here that don't have names on them. Did everybody go? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Did I miscount? Who didn't come up and sign up for one? Who's away?
I'm gonna wait till like 20.
You're gonna wait till 20. Why?
Because I didn't do any of them, so I gotta do stuff.
Oh, I see. Okay, well, host, I'm gonna put you up here. Host, here. All right, and I'll do the rest. So, Simone, come on up and take care of number 1, and I'm gonna start walking around the room, and I'm gonna start over here with you.
Yeah, no.
Are you gonna have like the formulas? Because I know this is the.
Just running. And then the rectangle is just raised them. Sounds like you know all the formulas.
Well, it's because like for the homework I struggled with. Well, I only struggled because it's not paper.
Yeah. It is tricky. So when it's on the screen, there's a couple things you can do. One is you can put your fingers on the screen and say, okay, there's the triangle. And you say, okay, 3 wide, 1 tall. So as you say that, right, 3 wide, 1 tall, you write down on your paper, you write 3 wide, 1 tall. And now you have something that's on your paper.
Also like 0 to 5.
Well, yeah, and it's better practice. But we couldn't do the area of this triangle and then the area of this triangle.
But wouldn't this be a shape?
Yep.
But I tried doing that.
Well, somewhere in the details, if you took a picture of your work, whatever you wrote down and then sent out to you, have to look at it.
Oh.
Or you have to say this is all one triangle. So if this is one triangle and it has a width of 5, then the height of 1. So we can say, okay, I've got 1 triangle, it has a width of 5, the height of 1. So 1/2 base times height, that's just half of 5, which is 2.5. So this whole negative area is just negative 1/5. Now we're going to divide the 8. So divide the 8 with this triangle. So this is 1 by 2. So 2 times 1 is 2. 2 times 1 by 2 is a positive 1. And this is 2 by 2. So it's 4. Yeah. $5 minus 2.52. Here you go.
That's all I wanted to know. But it's just what it's saying.
Yes. Anything that's below the x-axis is negative there.
And I can count like this as a height.
No.
Without having to split it.
Yeah, you sure can. The only thing would be like, what if the question was actually from 0 to 2? Well, then you have to split it because you're only. This one happens to say 0 to 5, which is the whole thing, so you treat it as one big triangle. If it said 0 to 2, you don't do that. Or if it said from 2 to 5, then you don't do that. And then you just split it in any which way you want. Okay, Allison. Oh my gosh, how much good for these?
Yeah, they're really filling you.
Well, I think that's the whole goal. Nail replacements. Okay, which one?
6.
Okay, so first thing you want to jot in is that even though these are telling you the numerical values of those areas, that area is technically positive and that area is negative. So fill in those numbers by putting plus and minus. There you go. Already that's much better. So like this first area is going to go from 0 to 5. So you just look from 0 to 5. There you go. You're just adding them together. You're not subtracting them together. You're just adding all the areas. So yeah, that area is just 8 minus 3 is 5. That's it. From 5 to 10? From 5 to 10?
Well, I guess,
That's a plus 1 and that's a minus 1. Yeah, 0. Very good. Super. All right, folks, let's take a look at Simone's first answer, and then I'll do number 3 with y'all. So with Simone, she was doing the beginning of the time interval. She was using the time from the beginning of the time interval. So that means if you were to have made a graph, right, and so you have your graph, and then it's going to be 0, 13, 26, 39, 52. I bet a lot of you have simply memorized how to take the data off of this, that if you're doing the beginning of the time interval, that's the left end point, then you're using these, right? So that's the left end point. Whereas if you're doing the end of the time period, that's the right end point, and then you're using these. I've seen a lot of you write down something that looks like that. So I think you've probably all memorized that the left end point means you're using the first chunk of data values, and then the right end point means you're using the second chunk of data values. And then you're multiplying by the common width. And that's true. But if you were to actually look at the graph and then say, okay, I want to use the velocity at the beginning of the time interval, so then this would be, oh gosh, it's so laborious to make a graph, isn't it? This would be 25, 30, 35, 40. So the beginning of the interval would be at 32. There we go. And then 39, and then 37, and then 29, and then 37, and then 26. So if we use the velocity from the beginning of the time period, I would make my rectangles by using the point on the left, like so. There we go. And that's 1, 2, 3, 4, 5 rectangles going all the way from 0 to 65. And the height are the heights given by the first 5 numbers. And that's what Simone, I think you and I have the opposite numbers up here. Which one of us is right, folks? Is it, what's that?
Is it you?
Is it me? Is it supposed to be the 32 first? So here, I'm just going to adjust this a little bit. It's 32 plus 39 up to 37 times the common width of 13. And then this one goes from 39 up to 26. Okay, there we go. So what? Those answers are just switched. So this answer is actually 2262, and this answer is actually 2184. Now, folks, I made an answer key. Is that correct? Does that jive with the answer key that I made? Or did I make a mistake on my answer key? Does anyone have it up in front of them? Sadia? This is correct. Oh, I made it wrong. Oh my gosh, did I really? I'm so embarrassed. Yeah, well, I even wrote it left. Oh. Well, thank goodness. Okay, my work is wrong. My work is correct, but I put them in the wrong spots. So at the beginning of the time interval, I showed all of my correct work for the right interval. And then at the end of the time interval, I put all of my correct work for the left interval. So I just need to switch where my work is located. But the work is correctly located. That's the right endpoint, and that's the left endpoint. Okay, thank you, Sadia. So in other words, I'm sorry for the confusion, folks. You need to switch my work there so that you're actually using the left. But I did correctly label it up here. Left endpoint means you're using the first chunk. Right endpoint means you're using the second chunk. Oh, man. Thanks. Yeah. Okay, any other questions on that particular problem? I'm so sorry that I wrote that backwards. Simone.
You have another practice test.
I'm not sure. I think I took most of them home and put them under my pillow. Chapter 2. You're lucky. I do have more copies. Does anyone else want another copy? I have quite a few here. I have 4 practice tests. Who wants one? Anyone else want a practice test? I'm not even charging for them.
This is the wrong one.
See it? What? This is the wrong one.
Oh, okay.
Oh, man. Simone, no, I don't think I have another copy of the practice test.
Okay, thank you.
Do you not have it with you?
I do.
Oh, you do? Oh, you just wanted another one. Okay. Gosh, where is it? Ah, here we go. Okay, for realsies this time. I have a couple left. There's one. Who wants one more? Did Michelle say?
So when it's asking for the beginning, it's asking for the left.
Yes. Which makes sense because if you're looking at the beginning of the time interval, the beginning is on your left and the end of the time interval is on your right. So beginning means left end point and end means right end point. Okay, now number 3. Goodness gracious, I wish that was all on the board so I could write on it. End means right, beginning means left. There we go. So, approximate the area under the curve of a parabola from 1 to 3. So here's 1 to 3. And I'm going to use right endpoint approximation with 4 subdivisions. So let's all remember how to calculate the width of a rectangle. The width of a rectangle is equal to the overall length of the whole interval divided by the number of rectangles that you want. So in this particular case, the overall length is 3 minus 1, which is 2, so 2 units long. And the number of rectangles I want to use is 4. So the overall width of each rectangle is going to be 0.5. So I start at 1, and then I say 1 plus 0.5 is 1.5, plus 0.5 is 2, and plus 0.5 is 2.5, and plus 0.5 is 3. So that's the markings of my rectangles. There we go. There we go. So those are my rectangles. They're not rectangles yet. I have to cap them off. And I want to use a right endpoint. So that means that for any given rectangle, I go to the line up on the right, and I make a rectangle there. So there's my right endpoint. There's my right endpoint. Here's my right endpoint. And here's my right endpoint. So this is definitely an overestimate. And yeah, it just says approximate. They don't tell me what the function is. So I'm just going to approximate by looking. I'm going to say that's around 2.2 of a height. That's around 4.1 of a height. That's around 6.5 for a height. And that's around 9.2 for a height. So that's the heights of all of my rectangles. So now my overall area, which is base times height, all the bases are the same. 0.5 times the height of 2.2 plus 0.5 times the height of 4.1 plus 0.5 times the height of 6.5 plus 0.5 times the height of 9.2. And you'll notice I just got a different answer from what my answer key stated, because again, these are just approximations. So depending on how you draw your rectangles, you might get a slightly different answer. But we should all be in the same ballpark. Yes, that's right.
Couldn't you just do like the 1.5 squared? It's showing you y equals x squared.
I need to. I should just sit down for a second, guys.
Oh, that's
Yes, you're right. That is the actual formula. Oh man. So this height is actually 2.25, and that formula is actually 4, and that formula is actually 6.25, and then that formula is actually 9. I suppose psychologically that's interesting to note. My values were close, not perfect, but close. So yes, Hostway, you could just use those values and then you'd be getting the exact answer for that Riemann. Silly me. I thought that there was no function, but there was a function. So by approximating it, 2.2 plus 4.1 plus 2.5 plus 9.2, my approximation was 11, but the real answer should have been 2.25 plus 4 plus 6.25 plus 9 was 10.75. Okay, so yes, folks, thank you, Josue, for pointing that out. If you want the height of your rectangle, you plug your input into the function. So 1.5 squared is 2.25, 2 squared is 4, 2.5 squared is 6.25, and 3 squared is 9. Oh, sorry, thank you. I'm going to slow down and read everything that's on the screen. Now, let's see, nobody signed up for 4, so let's also look at 4. 4 is the one I was thinking about that did not give you a function. So to do number 4, the key is drawing good rectangles. We're going from 1 to 5, and we're doing 4 subdivisions. So again, the width of one rectangle is the length, which is 5 minus 1 over 4 rectangles, which is 4, so that's 4 over 4, which is 1. That's easy. Each rectangle is just 1 unit wide, so these are your rectangles. And this is doing a left endpoint approximation. So for each rectangle, you go up the left-hand side and draw a rectangle. Go up the left-hand side, draw a rectangle. Go up the left-hand side, draw a rectangle. Go up the left-hand side, draw a Folks, for a problem like this, I'm looking for your drawing. You know, I want to make sure that you have a good left endpoint drawing. Now I'm just going to approximate all of these. So that height I'm going to say is 1.3. That height I'm going to say is 1.8. That height I'm going to say is 2.3. And that height I'm going to say is 2.5. And each width is a width of 1. So the area is base times height, which all of the bases are 1. So 1 times 1.3 plus 1 times 1.8 plus 1 times 2.3 plus 1 times 2.5. And you'll get your approximate area, which is an underestimate. I got 7.9 this time. Cynthia, what was the answer, key answer for that one? Oh, the exact same thing, 7.9? Wow. Okay. Wonderful. Now some more people can come on up, write down some solutions. I'm going to keep walking around the room and taking your individual questions. So, number 5, Efren, come on up. And where was I? Just talking about
Yes. Okay. Did have a question. Actually, just about. I think the one thing that I struggled on actually was this one, on the homework, or I think it was just mainly finding the estimated range.
So what question would you like to ask about it?
I know I had one.
I will come back.
Sorry.
Oh, sorry. Thanks for pointing that out. That's right. What's your question? Are you keep going? Synopsis.
Not yet.
Okay. Did you find this in
But
Okay.
no, that's I'll let you know.
Fine.
Record right now.
Great. See you later. Any questions?
This one. So for this one, the area
Yeah, so like it has a width of 1 and a height of more than 3. So roughly speaking, the area is 3 times 1, which is 3. It's a little more than 3. So to find those actual heights, you plug your input value into the function. So your function you already wrote down. So if you plug in 1, that's negative 4 times 1, which is negative 4 plus 4, which is just 1 minus 4, so $3.75. So that height is $3.75. That height right there. And then this height, if you plug in 2, negative a quarter times 2, that's negative 50 cents. 4 minus 50 cents is 350, so that height's 350. And so now, trapezoid formula. Yep. Which is 1/2 times p1 plus p2 times height. And technically, turn it sideways and say, okay, that's p1 plus p2. Yep. Okay, let's look at Efren's answer real quick. Oh, hey, very nice. So to find the blue shaded area, we know that we're doing an integral from 1 to 2. So the a value is 1 and the b value is 2. The actual function itself, f of x, you can find because it's a linear function. So it has a slope of down 1, right 4, and a y-intercept of 4. So the equation is negative 1/4 of x plus 4. That's your function. And then the overall area, Efren, I don't know that I got 7.25. You're using the trapezoid formula, right?
Yeah.
So the trapezoid formula is 1/2 b1 plus b2 times the height. And for a trapezoid, we're going to turn our head and look at it this way. Our b1 and our b2, and then the height. So what's the actual height, Evan? 1. So we change that to a 1. Did I make that mistake on the answer key again?
No, I just looked at the number 2.
Oh, okay. All right, so then those just add together, which is 6 or 7.25 divided by 2, which would be something like 3.625. Is that the answer? Okay, good. Okay, great. Thank you, Efren. Now, how did Efren get the heights? Since he has a function, he wrote y equals, but we could just as easily write f of x equals. How do you know the height of a graph? Yeah, you plug the input in and it gives you the output. That's one of the main key ideas from this class that we should all have totally memorized, that f of x is the height of the graph, or the y value, f prime is the slope, and f double prime is the concavity. So if you ever want to know the height of a function, you just plug that input value from the bottom into the function and it tells you the height. So that's how Efren got that this height was 3.5, this height was 3.75, the overall width was 1, and therefore you can calculate the area of that trapezoid using the trapezoid area formula. All right, thanks, Efren. And my phone just went off, so we might as well take a break. Let's keep going at 12:01. Oh, sure. Now, let's see here. Oh, yeah, I think that was the only day you were absent, huh? We better check on you. Now, I noticed a bunch of high school students wearing an S.
Yeah.
It's a yellow shirt with a black S.
Was one of the, because we're having, later we're having like an assembly.
Uh-huh.
For Halloween. And it's the best class, the class that has like the best.
Oh, I see. Okay, so this was. What day was the PSA? Oh, it says it right there, no, the 24th? So let's see. But you were absent on the 23rd. Was the PSAT on a different day?
We didn't have.
So what am I doing wrong here? Oh, did I write the wrong date on this?
Yeah.
Okay, 8/10, and then 15/17. Oh, and then 22, 24. I have my dates shifted by 1. Okay, well that makes sense. And then that was the day. But every other day, I see your signature, which means you were either here or you asked another student to plagiarize your signature. But I'm guessing that means you were here. Okay. Okay, that goes all the way up to 10.1. Super. So,
My friend is
Oh.
I think that's what they wanted. All right. Thank you.
Oh.
That's why they have to do that. Yes, that's why everyone needs one.
I'm sure it's not exactly 0.1. Typically, the program needs 4 decimals. So we're gonna do -1/7 minus a negative, that's plus 1/4. It's 0.1071. You're making it 4 decimals. Sure.
No, I.
Kind of go talk to my wife and all.
How many be able to do that?
All right, folks, it's 12:01. Let's keep going. We are on now to 6 and 7. Alexis and Michelle. Come on up and show us the solutions. And I will continue walking around the room to help out. So here's 6 and 7. And that's Alexis and Michelle, and here's some markers. Oh, good, plenty of markers. Where was I? Steven, yes.
Yeah, I actually did have a question.
Okay. Okay.
So, I actually like what you talked about there.
Okay. So whenever you have this notation, which is always on the A to B is from left
I
to
don't want
right.
to stand on the.
So you might even want to write that down.
Oh.
Integral
I'll just make it.
is the left, the right. Meaning along the x-axis, how far are you shaping? So we're going from 1 to shape.
1 to 1.
Yeah, so this is your A value, this is your B value.
Okay.
So far we have an integral from 1 to 10. These numbers are always telling you where along the x-axis are you marking off where you actually shaping.
Okay.
Okay, so then that's just 1 and that's 2. So then our function is just whatever the function is. And this is a straight line, so it's x plus b. And it's a negative slope, so I know that m is a negative number. And back in, just pick 2 points on the graph and calculate my slope to be down 1 right there. So that's my slope, and then my y-intercept b is just 1. So there's my function. How's that sound?
So good, yeah.
Okay, so now we just need the area of that thing. To find the actual area, if you're trying to look at it, that's a trapezoid. The formula for the area of a trapezoid. Formula for the area of a trapezoid. Okay. Base 1 plus base 2 times the height. So if we look at this trapezoid, this is base 1, how long that thing is. This is base 2, how long that thing is. Then the height is how long it is. The height is obviously 1.
Yeah.
So B1 and base 2, how do we find those? Well, that's just the height of a function. So you plug 1 into the function value, which is this. And you can do it on your calculator or your head. You plug 1 in right there, that's negative 4 plus 4, which is 3.75. Okay. So this height is 3.75. And I plug 2 into this function, so negative 4 times 2, that's negative 50 cents plus 4 is $3.50. So now I have my B1, my B2, and my height, and I can plug it all into this one. So half 3.5 plus 3.75. All those equal. And whatever that is, that's the area.
Okay.
And we can just roughly estimate the area because we just say, okay, well, roughly that's how far it is. Then it has a width of 1 and a height of 3, more than 3, so 3 something. And that's the area.
Okay.
Okay.
That makes sense.
Okay.
I appreciate that.
You're welcome. Okay, let's review Alexis and Michelle's work real quick. For Alexis, she was computing the area from various points, so from 0 to 5, or from 5 to 10, or from 0 to 10. So keep in mind, the purpose of this problem is to remember that area above the axis is positive and area below the axis is negative. So when we say A1 is equal to 8, that's really positive 8. And when we say A2 is equal to 3, that's really negative 3. And when we say A3 is 1, that's really positive 1. And when we say A4 is 1, that's really negative 1. So now it's just a matter of adding them up. Using your hands is very helpful. If we say the integral from 0 to 5, we're just looking between 0 and 5. And so you look at that area, that's 8 minus 3, the answer is 5. And that's what Alexis put. And then here we're doing the area from 5 to 10. So from 5 to 10, that's 1 minus 1, that's 0. So the total area is 0. And then this one from 0 to 10, that's the whole darn thing. 8 minus 2 is 5, plus 1 minus 1, still 5. And that's the areas from a graph. Questions on 6? Then number 7, thank you very much, Alexis. Now Michelle is doing the area for this graph. And this graph, they didn't just tell you the areas, you actually had to compute them by yourself. So this is a lot of triangle formulas and rectangle formulas. So recall, the area of a triangle is 1/2 base times height, and the area of a square or rectangle is just base times height. So you can tell that what Michelle did was she first found the area of this triangle, which has a width of 2 and a height of 1. So 2 times 1 is 2, cut that in half is 1. So that's your area of 1, which is really -1, right? And then this triangle has a width of 3 and a height of 1. So 3 times 1 is 3, cut in half is 1.5. That's a -1.5. This triangle has a width of 1 and a height of 2. So 1 times 2 is 2, cut that in half, that's 1. That's +1. I'll just put a positive just for the sake of being very clear. And then here, that's a rectangle with a width of 2 and a height of 2. So 2 times 2 is 4, and that's +4. It's nice to have the pluses and the minuses so that we're always thinking very clearly that some areas are positive, some areas are negative. Okay, so what does she do? From 0 to 5, that's this chunk. So that's -1 plus -1.5, that's -2.5. From 5 to 8, that's this chunk, which is 1 plus 4 is 5. And then this chunk from 0 all the way to 8, you just add them all together. 5 minus 2.5 is 2.5. Questions about those two? All right. Well, let's keep going. Let's see, there was no number 8. 9, I'll do number 9 since you're all still watching. Let's go ahead and do this one, number 9. Now, folks, this problem is on the test. Okay, I want you all to know that it's on the test. This is a good problem because it makes you think about what you're looking at. So we're saying that the slope is given by this formula. And we'd like to know what the graph is doing at x equals 1. So remember how I talked about making a little sketch, a little graph? I want to know what my little graph looks like at 1. Well, I don't know where my function is. Like, I don't know the actual coordinate, so I'm just going to pretend that I know that the coordinate is right there, and I'll call that f of 1. Okay, so I'm really ignorant. I don't know what f of 1 is. I don't know what the height is. It could be way up there. It could be way down there. The point is there's a coordinate somewhere, and wherever that coordinate is, I'd like to know what's happening there. Is it increasing? Or is it decreasing, and is it concave up, or is it concave down? So, first thing I can do is find out if it's increasing or decreasing by just plugging 1 into the derivative formula. So, f prime of 1 is -4 times 1 plus 5 is 6 times 1 plus 2 is 3, and that gives me a negative number. Right, I don't even have to keep computing. I already know it's a negative number. I can go ahead and calculate that it's -72, but it wasn't necessary. I know it's negative. I know it's decreasing, and so I know I can go ahead and put a little decrease mark on my little sketch. So now I need to know, is it concave up or concave down? So there's a couple different ways you could do that. I could go ahead and just compute the slope just to the right and just to the left, and then I can compare those slopes to the slope I already have, and that will tell me if it's concave up or concave down. And in fact, that's how I'm going to do it. I'll calculate the slope just to the right. So f prime of 1.1 is going to be -4 times 1.1 plus 5 times 1.1 plus 2. So that slope is -75.64, which is more steep, even more steep. I can already tell that it's concave down because that one was more steep. So now it's pointing even more down than before. Whereas if I do f prime of 0.9, that's -68, which was less steep. So I can tell that my graph is rounded down. It's concave down. So I'm decreasing concave down. That's one way to find your answer. Now, folks, to get credit for this problem, you do have to show me some sort of work. So if that's the work that you want to do, by calculating the derivative 1 and just to the right and just to the left, that's fine. Or if you want to actually FOIL that and take the derivative to get the concavity, you can. So f prime is actually x squared minus 28x minus 40. And if I take the second derivative of that, I get -8x minus 28. And if I plug in 1, that gives me -8 minus 28, which is -36, which is a negative number, so it's concave down. So, folks, it's up to each of you to choose what's your favorite. Do you want to FOIL it and take the second derivative? You can do that. That'll tell you it's concave down. Or do you want to take the derivative just to the right and just to the left? Both of them will tell you that this graph is concave down. Makes you wonder, is there a third way to do the problem? Is there a third way to do the problem? Yeah, actually there is. If you take the function f prime of x equals negative 4x squared minus 28x minus 40, I'd like to know what the function is, so I take the integral. The integral of negative 4x squared minus 28x minus 40. If I take that integral, it's going to be add 1, divide by what I get, and then add 1, divide by what I get, and that's x to the 0, add 1, and divide by what I get. So there's my function. So check this out. I just integrated. I just found out what the actual function is. And now I go to Desmos, and I can actually just graph that function. Negative 4/3. Negative 4/3. That's x cubed minus 14x squared minus 40x. And take a look. At x equals 1, well, x equals 1 happens to be way down there. Okay, so this was a little less helpful than we might have thought. But you can already tell that f of 1, which is going to be, where's 1? 1 is right here. So you can just guess. Take a look down below the 1. The graph is obviously concave down at that point, and it's decreasing. Right? This graph is decreasing, and it's concave down at that point. So that was a third way. Is there a fourth way to do this problem? Well, sure, maybe. But we don't need to do that. Okay, what do we have now? 10 and 11? Come on up, 10 and 11. Which is David and Allison. Oh, well, there you go, David. Did I get a far something here? Okay. See that? I just got to talk. See that? You asked the question? Okay. Yeah. How's your card in here? It's fantastic. Really? Did you get this? Yeah. What was on it? Oh. Okay. Next question. You can always take out the yeah, because that way it just gets it out of the way so you can focus on the main idea. Okay. Yeah. Another question? David? The actual formula? Well, you just think, well, there's a line, so that's mx plus b. Right? It's final slope, so I just picked 2 points there, this point, this point. So now I know something down 4, so that's negative 4. Good question, David. Yeah, Brendan. Question. Right now? Okay. Sadai, am I finally pronouncing your name correctly? All it took me was a couple months. Okay, so you need to find the area of each of those triangles in that case. You've already got that. No, it's not. So what's the area of a triangle? 1/2 base times height. So the base is 1, the height is 2. So you're going to do 1/2 times base times height. Stop right there. You did 1/2 subtraction. That could mess it up in your calculations. If you're going to do the 1/2, you have to put in parentheses to make sure that you're computing everything else correctly. So if you're going to do the 1/2 that way, you can. Or you can just do 0.5. Because 1/2 is 0.5. So 0.5 times 1 times 2. Yeah, so that's positive 1 right there. So this is x 1. And then this one is a height of 1 and a width of 3. So you're going to have to do 1/2 base times height. There you go. So that's a negative 1.5. And then that one. Yeah, negative 1. Because it's below. Yep, that's regular numbers. And then I get what? Oh, the overall length. We're computing it from 1 to 3. So how far is it from 1 to 3? Yeah. Very good. Okay, folks, these next two questions were pretty fast. We want to find the derivative of an integral. And we all know that the derivative of an integral cancels out. Oh, which just gave me a great idea for the name of our son. If we ever have another son, what if I'm going to name him Ted? But what if I named him? Oh yeah. Now, see, wouldn't that just be an amazing name? You could probably put that on a birth certificate. So like people would be like, oh, what's your name? You're like, just Ted. Your name's just Ted. Because the derivative and the integral cancel each other out. Wouldn't that just be wonderful? Oh, it'd be so cool. I'm gonna have to talk to my wife about that. All right, so the integral and the derivative cancel each other out. Oh no, it'd look better if I wrote d dx integral Ted dt. There we go. Now the derivative and the integral cancel out, and you're just left with Ted. Okay, so in this case, that's all we were doing. We're taking the derivative of this integral. So it cancels out the integral and replaces the t with dx, and so it's just x to the 7th. Same thing here. You have the function, which is all this, and you want to find the second derivative. So first you do the first derivative, which is simply this formula, replacing all the t's with x's. And then you actually do take the derivative of that formula using the normal power rule, and you get 3x squared plus 12x. Okay, yeah, very good. So is David and Allison? Thank you, David and Allison. All right, so the next one. 12 and 13, who signed up? Oh, goody, someone did Dave. Diego and Cydia. Okay, super. Well, where's your work? Yeah, so these terms are correct. You move that to be 3x to negative 2. You subtracted one. And then divide it. Yeah. There you go.
Isn't it amazing how something so little, it's just fascinating, isn't it?
And why is it?
No.
Okay, let's see. Oh yeah, okay, good. So oh good, yes. So you manipulated the whole thing. 4 x to I'm just checking. Okay, so 4x with 3 things and 6 x. So you add 1, divide by what you get. Add 1, divide by what you get. Very good. So that the 8 fits that. And then 6 times 2 would be 12. You actually did 6 divided by 2. It's 6 divided by 1/2, so that's okay. Yeah, that's it. Then I just go back through, replace that 3 with a 12, and then you should get the right answer. Super. See ya. Oh, you're going up there? Oh yeah, go ahead. All right, I made my way around the room once, so I'm coming back. Oh, I never got through this. What the? Necessary to get the same. So this one, they actually do give us a function. So we know it's y equals x squared. And we're going from 1 to 3. You got the widths, which are 0.5. So you know that you're going to do 1, 1.5, 2, 2.5, and 3. Those are the markings. And we want to do the right end point. So you're using this height. And then, why does it go 3 and then 2 and then 3 and then 2? Well, you put the 2.5 technically right there. It doesn't matter. Let's not change your whole drawing. But since we want to use the right endpoint, you would use 2.5 and then plug 2.5 into the function. So 2.5 squared is 6.2. I'm sorry, that's a 1. I can't tell that. I'm sorry, that's a 1. 1 and 0.5 squared would be 2.25. So that's the height of that rectangle. That's a 1. Well, the width of each rectangle should be 0.5.
Yes.
No, okay, so you're starting at 1. What's 1 plus 0.5? What's 1.5 plus 0.5? What's 2 plus 0.5? And what's 2.5 plus 0.5? Yeah. So see, you're using this number to bunny hop your way along the axis. And that's because I'm sorry, I was doing it wrong. I didn't realize there was an actual function. I was just approximating. But you don't have to approximate there's an actual function. Well, because this rectangle right here is as high as this point, and what is the height of this point? Well, that's the x value. The y value, you plug 3 into x squared. 3 squared is 9. So that height is technically 9. So that height right there is 9. This height, 2.5 squared, is 6.25. And then this point here, 2 squared is 4. And this point, 1.5 squared is 1.25. So the heights of these rectangles are definitely 2.25, 4, 6.25.
So to get this height is
Yes, yes, that's always the way, because this f of x equals x squared. Remember, the function always represents the y value, the height. Yeah. Yeah, and I'm sorry I misled you guys. I was just, I forgot that there was a function right there, and I was just eyeballing it. But technically, you have a function, so you should use those values. You're welcome. All right, folks, let's review. Thank you, Diego. You did number 12. So Diego has an integral here, 6x plus 3. Hey, look at that. He first wrote it in a user-friendly form, so 6x to the 1 plus 3x to the 0. He then did the anti-derivative or anti-power rule. So we added 1 and divided by what he got. Added 1, divided by what you get. So now he had 6 over 2x squared plus 3 over 1x. He simplified that to 3x squared plus 3x. And he's going to evaluate from 4 to 9. So notice he did parenthesis minus parenthesis. He put in the structure of 3 something squared plus 3 something, and 3 something squared plus 3 something. And then he plugged in the number 9, and then he plugged in the number 4. So all of this is wonderful. This is exactly what it should look like when you write out your full solution. And what was that? Diego? Thank you, Diego. All right, and then number 13, Sadia. So Sadia is doing the integral of 5e to the x. The one thing Sadia could have done here to show a little work is just to pull that 5 outside. So it's 5 e to the x dx. And then we have a formula that states that the integral of e to the x dx is just e to the x. So that's 5 e to the x. And then there's a plus c at the end. So yeah, very nice. That's it. Questions about either of those integrals? So that's 12 and 13. So now Sarai and Sila. What up, Sarai and Sila? Do we need what? Yes. All indefinite integrals get plus c. All definite integrals are an area calculation. Aldo.
I'll try and get that right here.
Which one? Okay. Number this. Okay. So is that the problem right here? Yeah. Okay. So negative 5x minus 4x plus 2x. Okay. So let's start with your user friendliness. So well, you went from here straight to there, so you must have done a good chunk of it in your head. Did you feel okay with that?
Yeah.
You followed that? Yeah. Okay. I'm just going to write user friendly just to make sure. So negative 5x to the negative minus 4x to the negative 1 plus 2x to the negative 2. Oh, that's it. That's a 2. That's 2. And then plus 3x to the 1. Okay, so that's what we have. And now we're going to do the integral. So I'm going to add 1 divided by what I get. So add 1 divided by what I get. Now this is actually different. This is just a natural log. I should have written that. I'm just written all the rest. So that integral is just natural log. So we're just this one, okay, add 1 divided by what I get. And then add 1 divided by what I get. Okay, so where are we at so far? Yes, yes. You have a double negative here. That's actually a plus. There's that, and then 3 over 3,000 equals 3. Yep, very good. So then that's a negative 1.25x to the fourth, and then minus 4x, and then that's a minus. But since that was a plus, now plus or minus a minus. And then that is 6 over 3 is 2. Yeah, there you go. Yep, so now that's correct. Super. Let me know if you have any other questions. All right, folks, let's review 14 and 15 real quick. So 14 by Sarai. Sarai pulled the 3 away from the 1 over the x, pulled the 3 out front, and the integral of 1 over x is just natural log, and then she's done with the plus c. Anytime it's an indefinite article, an indefinite integral, you're going to do the plus c. Okay, thank you, 14 Sarai. 15, Sela. So now Sela has her integral. This is fun. You can see how she put the plus 1 there to remind herself how to do the antiderivative. So she did plus 1 divided by what she got, plus 1 divided by what she got. So that was just 1/2 x to the fourth plus 1x cubed plus the c. Yep. Nice solutions. You'll notice that some of these problems take a lot of work and some of these problems don't take a lot of work. And honestly, this particular test is only over 3 sections. It's really just to get the main ideas of integration. So the problems could be very short and simple like that. Let's, Simone!
I feel like you just said, like it's so simple that I may forget to even show my work. Because like now I can see like that last problem. I can look at it and I can tell it's 3 natural log of x. And I can just write that, right? And still get 4 points.
Well, you know, Simone, I'd be really torn. What I would really like to see as steps would be there's that, and then you pull the 3 out, and then we all have a formula that states that this is natural log, so then it'd be 3 natural log plus c. So I'd really like to see the intermediary step. And the reason I want to see the intermediary step is not because I'm a jerk, right? It's because what we're trying to do is build our communication skills, which would communicate to an audience member. See, if you were communicating to an audience full of amateurs, and you just went from here to here, they might feel very confused. But if you said, okay, now the 3 is a coefficient that comes out front, this is a well-known formula we have, the integral of 1 over x is natural log, and then there's there, you just have a greater probability of people following you. So I really want to see that other line of work. That would be my preference. Okay, thanks, Simone, for your question. Did I answer it?
Yeah.
All right. All right, 16, 17. Who's that going to be? So, oh, nobody. Okay, I'll do it. Oh, nobody wanted 16 or 17? My goodness. All right, everybody. I know that 17 is quite tricky. Let's do all this together. So 16, first of all, what do we have to do? The vast majority of you are looking at your papers. Do you want to see this one?
We have to rewrite.
Yeah? Yeah, you have to rewrite it in user-friendly form. So this would be 3 to 6 of x to the negative 2 dx. And at that point, it's just the anti-power rule. So you're going to add 1, divide by what you get. And we're evaluating from 3 to 6. And so this simplifies. That's a negative 1. And then you push the x to the negative 1 to the denominator. So it's negative 1 over x from 3 to 6. And then you have parenthesis minus parenthesis. And so that'd be negative 1 over 6 minus negative 1 over 3. And the minus negative, that's a double negative. So chop, chop. And you get negative 6 plus a third, which on your calculator would give you a 6. Or 0.166666666. Is that the answer?
That's what I got.
Oh, good. Okay, so this next one, it pulls together quite a few rules all at once. So let's look very closely. To write it in user-friendly form, the 3x to the fourth is already user-friendly. So you'd say 3x to the fourth. The 6 over x, Simone. What is 6 over x, really?
The natural log.
Yeah, it's
So
6
natural log.
times 1 over x. That way you can see that 6 is just a coefficient, 1 over x is going to integrate to become natural log. Okay, and then we have 3x to the negative 6, and then we have plus 5x to the 1/2. So that's your first step, folks. That's the very first thing that you would write down. to rewrite everything in a user-friendly form so that you could do the antiderivative, this you know is natural log, that you could do the antiderivative, that you could do the antiderivative. So now you do the antiderivatives. Add 1, divide by what you get. So add 1, divide by what you get. The antiderivative of 1 over x is just natural log, so that's 6 natural log x. And then add 1, divide by what you get. And then add 1, so 1/2 plus 1 is 3/2. Divide by what you get, 5 divided by 3/2. And now it's just a matter of cleaning all that up and make it look good. So this would stay 3/5 x to the 5th. This would stay 6 natural log x. Double negative here, and so that's 3/5. Well, actually, look at this one carefully, folks. That's 3 over 5 and x to the negative 5th. So as a big fraction, I know my 3 goes on top, my 5 goes on bottom, and the x to the negative 5th goes on bottom as x to the 5th. So that part is really 3 over 5x to the 5th. And then 5 divided by 3/2 is really 5 times 2/3, so that's 10/3 x to the 3/2. Is that correct? Is that what I do now, Scott? Oh yeah, and C. Plus C. Oh goody. Plus C is, very often overlooked. I just overlooked it. In my calculus class, we all joked about wanting to all wear t-shirts in class every day that said, plus a constant. Right? I mean, that'd be a hilarious shirt. You could sell that on Amazon, make $1 million, right? Or the t-shirt would just, instead of writing it out in English, you would just have a t-shirt that just says plus C. Again, hilarious t-shirt idea. Right? Okay, or not. Okay, let's keep going. 1819? You signed up for 1819. Brandon and Aldo, come on up. There you go.
Oh,
So yes.
oh, is it ready? C plus, yeah.
I think it's up to, well, this is a straight line, at least we presume it's a straight line, and therefore it's y equals a number. And we can find the slope by choosing points. So we can find the graph. Choose a point on the graph. So my slope is down 1, right? So I know that it's down 1, right? 4. And then my line is 4.
Okay.
Yes, it's just a straight line. So it's an extra.
Okay.
Define one more. Give that one. Wait, that was your only other one? Do you have no other questions? So you're totally fine. Totally good. Send it.
Oh, yeah, okay.
Yeah, you could choose a point just to the right and left so you can see the overall sweep of the curve. Or you can just FOIL this all out. So that'd be -4 times x squared plus 7x plus 10. And just root the -4, so it'd be -4x squared minus 28x. Okay. Great. See it. So now I have, that's my derivative. So now I can just take the second derivative and compute the concave. So my second derivative now from this graph would be -8x, or that function, minus 28. And so if I just compute the concavity at 1, it gives me -8 times 1, 8, which is -36. And therefore it's concave down. Well, that's because the derivative itself is negative. Yes. Yeah, no matter what. Because look, you're wondering, what is the graph at x equals 1? Is it increasing or decreasing? That's the first derivative. And then is it concave up or concave down? That's the second derivative. Remember, that's what those things mean. First derivative is increasing or decreasing, so you'd have to plug 1 into that. So you find 1. And concave up or down, is the second derivative, so you have to find f prime of 1. No, you don't. You don't have to do this. You don't have to do this. That's how I like to think about it. But you could instead just FOIL all that out, distribute it, and then take the second derivative, and that will tell you concavity. Because remember, second derivative tells you concavity, and first derivative tells you increase in frequency. Good question. You're welcome. David.
A question. So as well, how did you tell that was a, whatever that was?
Natural log?
Yeah, natural log.
That's a good point. See, if you had anything else like 3 over x to the 6th, you would immediately just write 3x to the negative 6th. And then you do the anti-power rule, so add 1, divide by what you get. Okay, so let's say that you did have 6x to the negative 1. Try to do the anti-power rule. Add 1.
Oh, 6.
Add 1.
Over 0. Oh,
Right, and then divide by 0, that's undefined, so that doesn't work. So the anti-power rule doesn't work on this.
Okay.
Which is why, therefore, you know that that has to be 6, 1 over x, which has a special rule, which is the natural log.
Okay, yeah, that makes sense.
Yeah.
Okay.
That's really interesting, though, philosophically. I mean, you've got something, it looks just like the power rule should apply. But the fact is that it doesn't. And that doesn't mean that there's no answer. It's not like that that doesn't mean that this is non-integrable. It is integrable just by a different rule. That's pretty interesting. Well, that's very interesting. Good question, Simo. Simo.
It's okay, I don't know. You know the estimated ones and like different numbers?
Yeah.
Wait,
Okay.
yeah, sorry.
Yeah.
I don't kind of get it.
First things first, you always have to write user friendly. So you've got order 9, and then 6x to the 1, and then 3x to this 1. You have to see that in order to do the anti-power rule, which states add 1, divide by what you get. Add 1, divide by what you get. That's the anti-power rule.
Yeah.
So you need to see the x and the exponents in order to do the power rule.
Okay, I got it. Thank you.
You're welcome. All right, let's take a look at these answers real quick. 18 done by Brandon. So Brandon did the integral from 1 to e to the 4th of 5 over x, which he broke down to 5 times 1 over x, which he pulled out to 5. And then the integral of 1 over x is just natural log of x. So that's natural log of x. And he's evaluating from 1 to e to the 4th. So then he breaks that into 5. Just to show more clearly, the step that he just did, he did 5 times parenthesis minus parenthesis. And in that parenthesis, he did natural log of e to the 4th minus natural log of 1. And then that gave him natural log of e to the 4th is 4, and natural log of 1 is 0. And that's where he got the 5 times 4 minus 0. So technically, there's just one little step missing here, and that's actually writing out the parenthesis minus parenthesis and plugging it in. Did you do that part in your head, Brandon?
No, I just.
Oh, it's right down there. Oh, man, I'm sorry. I didn't even see it. I just saw you go from there and then it equals up to there. Silly me. Brandon has it all written down perfectly here. One more big set of brackets.
Yeah, one more set.
Yeah, there you go. So, yes, he has 5 outside of the parenthesis minus parenthesis. So he has all that, and then that goes up to 5 times 4 minus 0, which is 20. Yeah, perfect, Brandon. Sorry I didn't see that. All right. And then number 19 was done by Aldo. Aldo had a straightforward integration problem.
Accidentally added, so subtracted.
Oh,
So
okay.
the answer is wrong.
What should it be?
25482.
254 what?
82.
Point anything?
0.625.
Okay. So let's see Aldo's work. He did 3x to the 7th plus 6x to the 5th. So the first thing he did was write it, well, it's already written in user-friendly form. So he added 1 divided by what he got, added 1 divided by what he got, and that gave him 3/8 x to the 8th plus x to the 6th. Evaluate from -3 to 4. So although you wouldn't put another integration symbol right here, because you already integrated it. So now you're using the evaluation line. Okay. So then he did parenthesis minus parenthesis. He's using the structure of 3/8 something to the 8th plus something to the 6th, 3/8 something to the 8th plus something to the 6th, 3/8 something to the 8th plus something to the 6th. And then you just type all that into your calculator, and Aldo got 25,042. Did anyone else get that? Cynthia, that's it? Okay. Okay, wonderful. Nice work there, Aldo. Nice work there, Brandon. Both those solutions look great. So we just have 3 more problems. 20, 21, and 22. So 20. Come on up, Josue and Steven. Question? Which one? Okay, so this is one of your favorite problems. Approximate the area under the curve from 1 to 5. So first of all, we're going 1 to 5. So that's the area that we want. Using a left endpoint, approximation of 4 subdivisions. So the width of our rectangle is the length of the interval divided by the number of rectangles. So how long is the interval from 1 to 5? Yeah, and then how many rectangles? So the width of each rectangle, 1. So that's to 2, to 3, 4, 5, and you'll notice that's 1, 2, 3, 4 rectangles, just like we expect. Okay, so those are rectangles, and they want a left and point. So just look at that rectangle. We want to go from the left-hand side and draw a line. And we'll look at the next rectangle, left-hand side, draw a line. Next rectangle, left-hand side, draw a line. Next rectangle, left-hand side, draw a line. That's all. So the height of this rectangle is that point. And the height of this rectangle is that point. The height of that rectangle is that point, and that point. Now, what are those heights? They don't tell us a function. So you just have to approximate it, and you just kind of look. Yeah. Alice, do you think the etymology of the name Allison was the son of Alice? Like Alice, like you got like Stevenson, that's son of Stephen. So Allison would be son of Alice, but it makes no sense because Allison is a woman. Maybe, I don't know. Okay,
No.
one question here.
I think I just probably got confused with this last one, but I think so we just did them all the intersection. So I think I just need to do like more.
I'm doing another one right now. Alexis, where's all your work?
My dad, I need to do something on my kids.
Oh, well, I'm here though. What question was
No,
your?
I know.
You don't want to? Okay, well
But
then,
I only asked for one.
okay, and the
The
rest
other,
of them.
the other one, I had to work.
Okay, that's fine. So one weekend or tomorrow or the next day or any day until Monday, if you have any questions, or you need to. Just do it. I'm available to talk to you. Yes, Allison, go ahead. Try it and then. Yeah. Oh, okay. So you have the setup, and then from there you actually have to give it. What's that? You what?
I wrote, like we had in the.
Oh, but you're not sure of that. Okay, so then I would start over with that one. There's plenty of room down here. So you have. So first of all, you split it into 2 fractions. So that's 8x squared over 3x and 9 over x. How do you feel about that?
I understand that, but like right here, so this would be negative. Or when you write it, it's negative on half, right?
All right, so now I have 8x squared, and that's x to the 1/2. So I can come up here and put x to the negative 1.
So right here you have 3 halves.
Right, I know. That's 2 minus a half.
Oh, okay, now I see that.
Okay,
So
good.
that's
Gotcha. Yeah, that's 4 over 2 technically. So 4 over 2 minus 1 over 2 is 3x.
Yeah, okay.
And then this one is 9x to the 1/2. So now I have 8x to the 3/2 plus 9x to the negative 1/2. And now you're ready to do the problem. So it took a lot of work just to get ready to do the problem.
So,
Okay, so then what's your question?
No, now,
Now makes sense? Okay,
thank you.
you're over. Huh. All right, folks, we have 5 minutes. Now, who is number 20? Oh, Josue, were you going to come up and write up number 20?
Huh?
Aren't you number 20? Oh, I wrote you down for number 20.
Yeah, I just wrote what you wrote though. I didn't know how to do it, so.
Okay, then. But you can still come up and write it down. Now you know how to do it.
On the right.
Oh, that's it. I'm so sorry, I didn't see it. My folks, I don't know what's wrong with me today. Josue, here's your work. Number 20, here's Josue's work. I didn't even see it. I was like, where is it? What is it? I don't see it. And the whole time you're like, it's right there. Okay, so Josue started by rewriting the problem as x to the 1/2, and then he, you can do this in any number of ways, but you have x to the 1/2, I'm sorry, x to the 2 divided by x to the 1/2, so you're subtracting 2 minus 1/2 is 3/2, and then you move the x to the 1/2 to the top as x to the negative 1/2. And then from here you can do the anti-power rule, so he added 1 and divided by what he got, which is there, and he added 1 and divided by what he got, which is here, and you did simplify one more step, Josue. So 8 divided by 5/2 would be 16/5 x to the 5/2. And then 9 divided by 1/2 is 18 x to the 1/2. Yeah. And that's how you had what you had. So this is yeah. So that's your actual final bit before you do the evaluation line from 4 to 5. And then what, you just plugged all that in? Okay. Okay, so yeah, folks, that is a tricky one. I would say, for all of you, in terms of figuring this out, first you have to split it into 2 fractions. So you have 8x squared over x to the 1/2, and then plus 9 over x to the 1/2. And then you can either do the division rule, which means you subtract 2 minus 1/2, or you can bump the x to the 1/2 up to the top. And that would give you 8x squared x to the negative 1/2, and plus 9x to the negative 1/2, which then gives you 8x to the 3/2 plus 9x to the negative 1/2, and now you're actually ready to do the integral. Right? So it takes a bit of work just to get yourself ready to do the integral. Okay, and then the rest of his solution. So 21. I know we did this one at the beginning of the hour, and who did this? Stephen? So you have your integral, you put it in user-friendly form, you did the antiderivative, at which point you would need that integration line right there, and then you cleaned it up to here, and then you plugged it all in and subtracted, you got 870. Did anyone else get 870? Was 870? Was that? Okay. All right, and so the last problem was the marginal cost function. Allison, did you want to volunteer to do that one? I'm just kidding, but you can walk me through it. Allison, what do I write down to set it up?
0 to 36.
Yeah.
And then you put 17 over x squared.
X to the 1/2?
Yeah.
And then what?
And then you bring the 36 out.
Maybe we were thinking about different parts, but you have 17 over x to the 1/2, right?
Oh yeah, 17 comes out.
And you need to bump that x to the 1/2 up to the top, so it's x to the negative 1/2? Oh, did you bring the 17 out?
Yes.
Okay, that's fine. You can bring the 17 out. But you would still end up with x to the negative 1/2, right?
Yeah.
Okay. All right, so now what? So what's the antiderivative of this? Add 1 and divide by what you get? What's add 1? It's negative 1/2 plus 1.
Oh.
Negative 1/2 plus 1, which is 2 over 2. Yeah, just 1/2. So that's x to the 1/2. And that's it, x to the 1/2, evaluated from 0 to 36. And what's x to the 1/2 really? By definition, it's just the square root. Right? X to the 1/2 is just the square root of x. And you're going to evaluate that from 0 to 36. So we then do parenthesis minus parenthesis. And what do you plug in? Yeah, plug in the 36 and then plug in the 0. And so then you have 17 times 6 minus 0. And so what is that? 17 times 6? Did anyone else get 102? Was it 102?
No.
No, it's not. What is it? What is it? How much?
No, it's 102.
204? Why 204? Oh, so for some reason I wrote 34. Oh, because I didn't divide by 1/2. You add 1 and divide by what you get. Silly me. So that was actually a 2 right there, which changes that to a 34. And then that's still at 34, and then you get 204. Geez, see, you see what happens when you don't follow through on your own verbiage. Add 1, divide by what you get. Add 1, divide by what you get. I wasn't saying it, and so I missed it. Okay. Well, folks, that's all the different problems on your test. What do we have here? No minutes left. So, see you on Monday. Please email me over the weekend with any questions that you have.
The test is Monday, right?
Test is Monday.
Number 22 was mine.
What?
It was mine.
Oh, it was. Oh, what? I'm sorry. There it was. I just dived in and started doing it. Silly me about that. You need